Okay, let's get started. Good evening, everybody. Can you hear me?
Yes, sir. Yes.
Okay, so in last class, we discussed about Maven installation and its dependencies, right? So this is our typical end-to-end build and deployment workflow. So this is our GitHub. We create the var file, and then we deploy the var file into Tomcat server, right? That's what we discussed. So here, one second. So this is your source code, correct? This is source code. So earlier, I just mentioned that you have some Java files, HTML, CSS, JavaScript, and so on, correct? So what we do, we clone this particular project here. We compile it using Maven. We create the var file, and then we deploy the var file into Tomcat server, correct? This is end-to-end build and deployment workflow. First is clone, second is build, third is deployment, right? 3 steps. So in real time, as a DevOps engineer, we'll be cloning the application project, correct? In our laptop, and then we do the build here. So as a developer, as a DevOps engineer, we don't need to worry about, what is there in this project source code. That is written by the developers. And it is development team who creates this, project folder structure. So go to any Java-based standalone application. You'll understand what is the meaning of standalone application later. Standalone application means which is not a web application. I'll explain that later. So in real time, any project, standalone project you take, it follows some structure. It will be having some project structure. And who creates that project? It's a development team. So as a DevOps engineer, just to be comfortable, it's good to understand the project structure. So how Java project structure looks like, folder structure. That's what I'm going to explain. So once you understand a project folder structure, then we'll clone it, we'll build it, and then we deploy it. Okay. So I'm explaining project folder structure. Okay. So this is how it looks like. For example, think that it's a Flipkart. Think that it's a Flipkart. So if you go to Flipkart, you see something like this. Okay. A root folder will be something like Flipkart. That is a project name. Paytm, Flipkart, Amazon, and things like that. In the Flipkart, you see one directory called SRC, meaning source. Under SRC, there will be 2 folders again. One is main, and the another one test. Main and then test. Under main, you see a folder or directory called Java. Again here, another directory called Java. Under Java, there will be something called group ID. Here also group ID. Under group ID, you see hundreds, thousands of .java files. Here also see thousands of .java files. Say for example, here you store .java files. Clear? Along with SRC, you see another file here called pom.xml file. Pom.xml file. In pom.xml file, usually we define build and deployment related configurations. More on that later. So that's how most of the Java-based project folder structure looks like. I'm skipping this one, okay? If you go and then see their GitHub repository, so this is the folder structure they have, whatever I'm showing here, okay? So now you may be having some questions here, right? First question. As per the slide, we have main, Java, group ID, and then see you have 10,000 .java files here. Here also, you may be having 10,000 .java files. Why we have some .java files here, some .java files here? Question, right? Very simple. In src main, we store, that means main folder contains main application code, your main business logic code, whereas test directory contains testing code. There's something called unit testing. So this folder contains unit testing.java files. And this is your main application functional code. So that's how developers create the project. That's how they store main application related .java files, test application related .java files. If it is not clear to you, right? Let me, explain what goes here, taking a simple example. Assume that you have calculator.java here. What's it? Calculator.java. So this is how they write calculator.java. So I'm writing this calculator.java here. So this is how they write code. And where is this calculator.java? This calculator.java is stored in this particular main, under main. So they write code something like this, okay? Calculator.java. Just take the concept at a very high level. As you know, we don't write any Java code. So they write code something like this. For example, here they write, say for example, A is equal to 10, B is equal to 20, right? Say something like this, okay? Add A comma B, okay? It's a function. And here they will write something like, C is equal to A plus B, display C, return C, something like this. This is how this code works. Developer is writing Java code for calculator functionality. Assume that in flipkart.com, you have calculator. Users can log in and then they can calculate something. Okay, the browser itself. So here, developer is taking A value from the user, B value is equal to 20. And then developer is writing a function to add these two numbers. What is the value of A? 10, value of B? 20. Okay. C is equal to A plus B, right? 10 plus 20. 10 plus 20 is 30. 30 is stored in C. Display 30. C means 30, right? Display 30. So 30 will be displayed on the screen. See the logic? It's a pseudocode, okay? Not real code. That's how developer is adding two numbers and then displaying numbers. So this is the main logic, right? Calculator main logic. So that main logic file will be stored under main. So 10 plus 20 is equal to 30, right? The result is assigned to this variable called 30. And then C is displayed on the screen. That means 30 is displayed on the screen. That's how it is working. So when developers write application code like this, they also write some Java code for testing this particular code. If you execute this particular code, this code will test this. See the thing? So we call this testing methodology as unit testing. Unit testing. Unit testing is the first level of testing that happens in software. Unit testing is the first level of testing that happens in software. And who writes unit testing code? Developers. And where this testing happens? In developers machine itself. So when developers write calculator.java, they write calculator test.java to test this particular code. So they write something like this. Say this is your calculator test.java. Calculator test.java. This file will be here in under unit testing code. So testing code is under test. Main application code is under main. Simple, right? So how this testing code looks like? Why developer is writing this particular testing code here? To test this particular functionality, right? Correct. So this guy writes something like this. Say A is equal to 100, some imaginary values. B is equal to 200. B is equal to 200. Then this guy is assuming, okay, I'm adding these two numbers, 100, 200. If I add these two numbers, expected result, ER, should be 300. Correct? If you add these two numbers, if you have to test, you need some input, right? So developer is assuming some input and then expecting the result, that is 300. That means this guy will send A is equal to 200, B is equal to A is equal to 100, B is equal to 200 to this particular code. If it gives 300 back, that means this code is working fine. That's how it works. Then developer is calling this function add A comma B. Sorry, I have a little cough today. Bear with me. Add A comma B. And then this guy is calling it as actual result, AR. Okay. Then writes some comparison code. If actual result is equal to expected result, okay, expected result, then test case is success. That means code is success. Else code is failed. I mean, test case is failed. Test case means a scenario. Assume that you have a calculator. Addition functionality is one test case. Subtraction is another test case. You can call it as a test case because it is testing a case. What's that case here? Addition functionality. Similarly, if you write some code for testing subtraction functionality, you call it as another case. So test case, subtraction case, addition case, multiplication, some math, sine theta, cos theta, or whatever, something like that. Now, this is the main code, correct? And this is your testing code. Let's see how the flow happens here. So what is that main logic? What is that main file we need for calculator functionality in Flipkart? And this one. Why developer has written this? To test this particular code. So once developer finishes writing calculator.java, this guy writes calculator test.java, usually file name and then test.java. Login.java, login test.java. That's how they follow usually. File name can be anything also. A is equal to 100. Assume that once you write this particular Java code, you execute this. What will happen? Tell me. A is equal to 100. B is equal to 200. Then it comes here, add. You're calling a function here, correct? add a comma b semicolon. So what is a value? 100. B value 200. And then you're calling a function here, correct? Add. The moment you say add 100, 200 here, it'll go and then execute this code. And then it will send input 100 and comma 200 to this particular add functionality. Add function. Now what is the value of A? 100. What is the value of B? 200. What is the value of C? 300. Correct. So C value has 300. And then it is returning C. So it will return 300 to this. So developer has some code, right? The developer is assuming some values with some assumptions, right? Developer is calling that code, invoking the code, calling that code. And then developer is getting the output of that particular code. And then this guy will compare now. So if you are calling this particular function, what is the result you will get? 300, right? What is the add a comma b value? 300. So 300 is stored in actual result. Now we see what is the actual result? 300. What is the expected result? 300. If 300 is equal to 300, that means code is working fine, correct? Assume that you get 3000. 3000 actual result is not equal to expected result. Since it's not equal, what it will do? It will say fail. That means what? If you are getting 3000 means test case is failed. That means there is some issue in the code. If you are getting 300, right, it will become equal, and then it will say yes, test case is success. That means code is working fine. Now we see how developer is writing the main code and writing a unit testing code. And as I said, this is the first level of testing that happens in software, and it happens in developer's laptop itself. Means there is a Harry here, right? This guy is a Harry. So if Harry writes calculator.java, Harry also write calculator test.java. So this is the main code. This is testing code, correct? And then developer runs this calculator test.java during the development itself. Okay. And then this code is tested. We have different testing methodologies, right? So today I've introduced unit testing, right? Then we have something called manual testing, automation testing, system integration testing, SIT, user acceptance testing, performance testing, and so on. Correct. So this is the first level of testing that happens during the development itself. What is the purpose of this unit testing? Why unit testing is required? Question correct. Why developer is working as a tester there? Why developer is testing the code? So unit testing purpose is to make sure that there are no basic issues in the application. Unit testing purpose is to catch a basic level of issues at the time of development itself, so that further testing goes smooth. Meaning, assume that developer just writes calculator.java. Developer just writes calculator.java. Developer has calculator.java here. Okay. You take calculator.java, compile it, calculator.class, calculator.class. Then comes tester. Tester is accessing the application. This is your Tomcat server. Developer is accessing the application. Sorry, tester is accessing the application. What if this calculator.class has some basic, level of issues, some basic issues? For example, this calculator.java, this calculator is displayed here in the browser. Sorry, the calculator itself is not displayed. Calculator itself is not displayed. Assume that developer is writing login.java, 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 login.class, login.class. tester is accessing the application. This login dot class has some basic issues. That means login button itself is not working. If login button itself is not working, can you log in and then test, cart? If you want to test cart, payment gateway, we should first log in, correct? So when I say basic level of issues, these are the issues. So if developer don't write, a testing code here, if they don't do a minimal testing, if they just push the Java code, we take the code, we build the code, then we deploy the code. So when testers access the application, they may get some basic issues, and those basic issues will block a further level of extensive testing. Assume that there is some basic issue here. What tester does? Tester, reports that issue to the developer. Again, developer modifies some code. Developer is not testing here, okay? Pushes the code. We take the code, new code. We again compile it, again we place it. Again, second time, again there is an issue. Again, you report the issue to the developer. It takes 1 hour for developer to fix. Again, 1 hour for you to clone, build, and deploy. So 2 hours. So first time 2 hours, second time again 2 hours. What if third time also there is some basic issue? Again 2 hours. 2 plus 2 plus 2, 6 hours. So tester, cannot test anything. You just wasted 6 hours of testing tester time. If this happens very frequently, can testing team complete their goals? Like, can they complete automation testing, integration testing, all these testings in time? No, right? As a result, what happens? Your release is 2 months release, and the developers are developing, but testing team is unable to complete the testing in 2 months. So you will not be able to release the code to the production. So this may cause huge delay in testing, and then a development also, because they also have to attempt multiple times. So how do you fix this problem? That's where we think about unit testing. So we tell this developer, hello developer, we know that you are a developer. We are not asking you to do any thorough testing. We have a dedicated testing team. Yes, we have. Don't worry. But when you write some Java code, don't just throw it blindly in GitHub, because that may cause a lot of basic issues. Instead, why don't you, do a basic level of testing? And what's that basic level of testing here? Unit testing. So developer writes this unit testing, and then unit testing code. When developer executes this unit testing code, right, what will happen? This code tests this particular main code. And if there are any such basic level of issues, developer can catch them at the time of development itself and then fix them. And then, that gives a minimum guarantee to you, right? And then this guy will push calculator.java, we take the code, we build, and then we deploy the code. And these guys work on extensive testing. So the purpose of unit testing is to catch the basic level of issues at the time of development itself. So that ensures, code quality also to some extent, right? So that unit testing code developers write here, and that main code developers write here. In other way, you can remember this unit testing terminology this way. Unit testing means the purpose is to test each and every unit of your code. That means we wrote this particular unit testing code to test each and every line of your main application code, correct? See, you're calling add a comma b. That means you're calling this function. That means what? You're executing this code, and then it is giving the result, correct? That means you're hitting this code, and you are getting the value of it, and you are checking. I should have 300. If I get 300, that means code is good. Otherwise, code is bad. Correct. So here you may feel that, okay, only 4 lines of code, this will always give the correct result. But in real time, just for addition, you may have to write 1,000 lines of codes. Correct. Say, for example, somebody deposits some amount in wallet. So you have to write the code to connect to that user's bank account, update, the money in the wallet, and then connect to the RBI database. I can do something there, blah, 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 blah. So when you write 1,000 lines of code just for adding funds, for example, right, things may go wrong there, and then you may get the wrong result, right? So unit testing's main functionality is testing each and every line of your code. For example, you also have to know this fact. For example, you have subtraction functionality. Okay, subtraction code in main, subtraction functionality in main code. Subtraction and then some code. So developer has two things here. One is addition functionality. Second thing, subtraction functionality. But developer, this time is not writing the code for testing this. This add functionality is testing only this add. There is no unit testing code for subtraction, right? It happens sometimes. If you go and ask developer, sometimes developers say, we are, under huge pressure. We are in the process of taking the product to the market, right? So this is MVP release, minimum viable product release. That means the basic level of version we want to, release as soon as possible in the market, because usually, the first whoever goes first in the market, they have that first advantage, right? So more quickly they can penetrate the market and things like that, right? So developer says, I'm not writing the subtraction code at the moment, I'll write it later, and that's business goal. So there is no guarantee. What I mean to say is, there is no guarantee that you should have unit testing code for testing each and every line of your code. One second. So what I was telling. So what I'm going to say is, you don't need to have, testing code for testing each and every line of your functionality code. Sometimes, priorities may change. But if you can have unit testing code to test complete functional code, it is good. In this case, for example, I can say I have 50% code coverage. What's it? Code coverage, 50% code coverage. That means 50% of my code is tested, right, using unit test, and 50% of the code is not tested. So usually companies have say 60 to 70% of the code coverage. That means it is good. It is considered as good. 60 to 70% of unit testing code. If 60 to 70% of your functional code is tested by unit testing code, usually it is considered as okay. Okay. So now you understand what is unit testing. Okay. First level of testing that happens in software. It happens in developers' machines itself to make sure that basic issues are not present in the application, so that the team can progress with their further level of extensive testing very smoothly. And then this testing code is stored here. This main code is stored here. Understand the meaning of unit testing? See, when you are, assume that you are a creator, right? You are creating something, right? You are developing something. You just go and then create something and then throw it on some other space? No, right? When you are developing something, you at least check, right, the basic things. At least once you execute and then you test it, right, before you hand it over to somebody. Correct?
I have a question.
1 second, Graham. Assume that you have a car manufacturing company, right? You first manufacture the wheels. Okay. You manufacture the engine. Do you know, once wheels, engine, car body is manufactured, you just fix it and then send it for testing? No, right? What do? You first purchase the wheel, right? Wheel. What you will do before you take your car out for testing, right? You first, fix this wheel to the internal machinery wherever you're manufacturing, inside in-house testing, right? Inside, small room, for example. You fix this to, some machine, you rotate only the engine. right? You observe the noise levels, performance, speed, and things like that. Then you test this, then you test this. So unit testing is like kind of in-house testing, okay? So whoever is manufacturing, they test it first. In software, it is same, okay? So that's the first level of testing happens in software. So as a DevOps engineer, we are not dealing, we don't need to deal with this code. Who writes this code? It's a developers, okay? Why I'm explaining this? Because see what happens here, when you join in real time, you'll be cloning some application code. The moment you clone some application code, you get a lot of doubts saying, there is some Flipkart, blah, blah, main test, blah, blah, and all the stuff. Sometimes, you try to understand, you will try to understand what is this main, what is this test. You get a lot of confusion. You think that, you're not comfortable and things like that. So just to avoid that confusion, right, I'm explaining this project folder structure. Otherwise, this is not our job. Having, high level idea is good. And in real time, when you're working, people will be, people will be talking about unit testing, code coverage, and things like that. So now you know what is unit testing. When somebody is telling unit testing, you know what is this, right? It is just for that. I have experience with this. When I joined as a fresher, I was having a referral. One of my classmates referred in his company. He got a job, I think 6 months or 1 year before than me. He referred me in the company. And we both were the only build and release engineers in that company. It's a small startup. First day, my friend told me build and release and DevOps were not taught that time. And this is not something we learn in academics, correct? We directly join and then we learn in the real time. Okay. So nobody used to teach all these things in the institutes. I was the first person, in fact, to start training in Bangalore itself, first institute in DevOps. I started that as a build and release because I heard somewhere in the Bangalore somebody is teaching in classrooms like this. So I've just taken that inspiration, and I was the first person to start training in Bangalore. So it's my first day, right? My friend came to me and said, just run this clone command, okay? Take the project in your laptop, run this Maven command, build it. I cloned it. And I was having this kind of folders, lot of things, even not just this, thousands of files and folders you may see. I asked him, what is this? What is this? What is this? He said, that's not our job. Just do what I say. Next day, same question I asked. Do what I say. That's not our job. Don't try to understand. So I remained in confusion, basically. Even he says that, not our job. Sometimes out of curiosity, you try to understand at least things at a more, at a high level, right? So if you don't have that easiness, what will happen? You will not progress further with, the other things. So just to avoid, just to eradicate, right, remove that feeling from your mind, I'm explaining the project structure. Otherwise, this is not our job. But hope you understand it, right? Any questions here? Go ahead. Kiran, you were having some question?
Yeah, actually, I was asking the same thing, that why we need to know this terminologies and these testings, different types of testing. Even the testers team are there, so why we need to know this?
Correct. You got the answer now, right?
Yeah.
It's experience, right? So if it is another trainer, they may not explain this in Maven class. It's trainer's choice whether they want to include some topic and things like that. So I am sure that most of the times you will struggle with this. That's as I wanted to have a separate topic. Okay. Any other questions you have about this? Any confusions? Right. So now you know the project structure. That will also help you to understand Maven in a better way, okay? So Maven standard project layout, project structure. Java projects which are built by Maven ideally follows below project folder structure. Flipkart, SRC, main, blah, 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 test, blah, blah, blah. So here, if you have app.java, here you have app.test.java. If you have calculator.java here calculator test.java. And here you have something called pom.xml file. What is this pom.xml file? So this is where usually DevOps in this work. So this is where we can configure, build, and deployment. I'll explain about this pom.xml file later. So I just gave some high-level explanation here. Flipkart is a project name, right? This one, first folder. It is also called as artifact ID. Remember, what's that? Artifact ID in Maven. SRC means source folder which contains the application source code. SRC main contains the main code, test contains testing code. And pom.xml file contains your build and deployment configurations. We'll discuss that later. So now you know the folder structure. Shall we clone a sample project and then do a quick build, right? So it is a Flipkart, and a Flipkart, what is it? What is that? SRC. Under SRC you have main, under main you have test. Here you have Java group ID, okay? Under group ID you have some Java code. Again, SRC test Java group ID, under group ID you have some code. Same thing. Okay. So when you clone this, what you will get in our mission? I'll get Flipkart, SRC, main, test. Under this, Java, group ID, and then some Java code here. Main application code, unit testing code. That's what we get. This guy is DevOps engineer. So first step is clone. Second step is build, right? So if you want to build this application, so we first clone the code. When you clone the code, we get this. And then if you want to build the application, we run a command called mvn install. That's a command we have to run. If you run mvn install, it will compile this Java code, it will compile this Java code, and then it will basically give you class files and a lot of other things here. I'll show that. Assume that you create the var file, and then you can deploy the var file into Tomcat server. Understanding the flow? Very simple, right? You have project structure. Our job is, compilation. We just clone the code. We run Maven command. We call Maven. Maven will compile and then create the var file for us. Clone, build, create the var file, and then deploy it into Tomcat server. Okay. So let's clone some project. So go to some folder. So I don't have anything here. Okay. I'm cloning the project. Assume that this is your first day in Flipkart. This is your first day in Flipkart. Your manager comes to you, says, hello, DevOps engineer. Before I put you on the real project, can you take, the sample project, build it, and then deploy it? A sample build and deployment, can you do it? So what will be your first question to your manager? Okay, I'll do it. Tell me where the source code is. So when you join in the project, somebody will give you your project repository URL. So you know how to take the code, right? Git clone. https://github.com/flipkart.git. That's a repository name. This is a public repository. After the class, you can also use the same URL and practice, or you take the code from this repository and then you create your own repository and then push this particular code. If you don't want to use my name and then this URL, you can do that. Git clone ls, go to Flipkart. I have an extra file here. Let me remove them. Don't worry. But there was one extra file, I just removed it. Okay, so I'm first cloning it, okay? So there is a project, I'm cloning it from start. What is the first command? Git clone. Git clone, okay? First step, you get the project. ls. You want to see the project folder structure now? Let me show that to you here in the file browser. Where is source? Source, okay? The source, you have Flipkart. This is what we downloaded, Flipkart. Under Flipkart, what is there? src main test, correct? src main test. src main test. Under main, what is there? Java group ID. Don't try to remember, okay? Main, src main, Java. Then I said group ID, correct? Group ID means reverse domain name. Remember that. The project name is flipkart.com, say for example. That's your project URL. Group ID will be com Flipkart. Remember that. That means under main there is a Java, under main there is a com, under com folder Flipkart, under Flipkart you have this. So group ID means what? Com Flipkart. So under Java you have com, under com you have Flipkart. Yes. If you're working for paytm.com, for example, com.paytm, that means Java com Paytm. Amazon.com, src main Java com Amazon. Under that you have the code. So group ID here is com.flipkart. Com Flipkart, see app.java. You have one .java file. Similarly, if you go to a real time, you will see hundreds of .java files here. So here you have app.java, right? Under test, app test.java, correct? Okay, go back to Flipkart. Flipkart, src main contains main code, test contains testing code. src test, Java, group ID, app test.java. So here under src, you have main test. Under main, you have main code, that is app.java, app test.java, a simple project. So once you understand a few things here, we'll go to another project which is like a little complex than this. Okay. So now you understand folder structure. So since we'll be drawing this diagram multiple times, you'll be able to remember this in the classroom itself. After the class, when you practice, try to remember the folder structure after the class, not now. Now just take the concept at a very level. Clear with this? Okay. And wherever there is src, there is a founder.xml file. So if you want to clearly see the structure here, you can use this command, tree dot. This command may not be there sometimes. If you don't see this particular command in your Linux lab machine. Install it. apt get update, apt get install tree. apt get update, apt get install tree. See this tree dot will give you the structure. So under this you have pom.xml src, pom.xml file src. So under src main java group id app.java you have src main java group id. Under src there is a test, right? Src test java group id. So here in the main you have the main code app.java. In test you have testing code app.java app test.java. So in real time you see 100,000 of .java files here, 100,000 of .java files here. Clear the structure? Any questions you have about this?
Sir, I have a doubt. Like there was internet issue for 5 minutes here. How did you get the POMF XML file? You created that or it was generated by
It was
Maven?
there in the repository, so I just cloned it here.
Okay, you created that, right?
In real time, who creates this particular folder structure? Who creates?
Developers.
Developers, yeah. So there is a Flipkart src main Java, group ID. Flipkart src test main Java group ID. And then here you have some Java code. Here you have some Java code. Who creates this folder structure and then writes, Java is there? Developers. So I've just cloned it as a DevOps unit. We just clone the project. Okay, see this. Everybody. Harry. Okay. Harry. Harry is a developer, right? Harry writes calculator.java. Assume that Harry is working on Flipkart. Harry wants to write calculator.java, new code. So if Harry has to write the code, he has to first clone the repository, correct, everybody? So what Harry do? Harry clones this repository. When Harry clones the repository, what will happen? He'll get the same code, right? Harry is cloning the repository for developing the code. We are cloning the repository for building the application. So when Harry runs git clone command, what will happen? Tell me. This will be cloned. So Harry will get Flipkart. Harry will get Flipkart test. Sorry, under Flipkart src. Here you have main. Here you have test. Blah 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 blah. This. So Harry will write calculator.java. Harry will write calculator test.java here. And here you have pom.xml file. So assume that first time, whoever is working in this project, they clone the empty repository. They'll get Flipkart, src, main, test, and all the stuff. The complete, project skeleton they create. So and then here you have pom.xml file. So he writes calculator.java here, and then git add, git commit, git push. Calculator test.java, git add, git commit, git push. So when his modification go here, his modifications go here. So pom.xml file, who creates? Developers create that. So they clone the same repository, they do their work, right? And in main or tests or wherever, and we clone the code for compilation purpose. Questions? Understand that? Is your doubt clear? Any follow-up question on this?
No, sir.
Okay. So if you want to build the path, what do? You first clone the code. Okay. I've given all the steps. I'll explain the steps later to you. Just listen what I'm explaining. Okay. From start, I'm a DevOps engineer. Git clone. I'm a DevOps engineer, right? I'm first cloning the code. You can also clone the same repository. Then I don't have any fear now. I know the project folder structure. I also know that I don't have to worry about this folder structure at all. It's a developer's job, right? Fix this in your mind. clone is done. Once clone is done, then we have to build it. So we cloned the code. So we got this folder structure here. Developers laptop. Then we have to build this application, right? Then who will build the application? It's a Maven, right? So I'll just execute a Maven command here. Maven is an automation tool, right? So once I clone, see, I'm calling Maven now. Hello, MVN. How do you invoke Maven? What's the command? For Git, it is Git. For Maven, it is MVN. Remember, I just say MVN install. That's a command we have to execute. See what Maven is doing now. First time when you execute MVN install command, it will take long time and it will download a lot of Maven related dependencies. First time. Second time, it won't download the dependencies because dependencies are already there in your machine. So first time when you run this command, it downloads dependencies, means think that it downloads some Maven related things in your machine. Okay. So clone the repository, just execute mn install. So when you execute mn install, what happens? That's a question, right? So now, see, this is called as an automation. You are running a command at a very high level, and Maven is doing a lot of things for you automatically. See this? Maven is compiling the main code, compiling the testing code. It is basically executing the code and then generating the reports. Okay, unit test reports, how many pass, how many fail. It is also creating jar or var file. See the thing. This is what we discussed, right, in the build process. You have .java. Basically, what is our goal here? We have to compile main code, right? Whatever Java files we have to compile this. We have to compile this, correct? And then we have to get the jar, var file, and so on. We also have to generate the reports, right? How many pass, how many fail. So it is doing all this stuff here. Think that today we have not discussed mvn install command. Think we have not discussed mvn install command. I don't want to bother you with too much thing. I can explain this in today's class itself. Let's not do it because if I explain this, you may get confused. So what you do before attending next class, okay, go through these slides first. Try to understand what is the main code, what is the testing code, okay? If you don't have this slide, just take a picture of this or take a snapshot of this. Take a snapshot of this. If you don't get time to go through the video again and again, recording, understand this. You try to remember, okay, this folder structure. Then go to your Linux machine, download the same project, whatever I have downloaded, like this. That means clone the project. You all have to clone the project in your laptop. Clone the project and then check the project structure. Check the project structure. Try to remember this structure. Go through the notes also. Okay. What is Flipkart? What is SRC? What is there in main? What is there in test? Try to understand this. Then, so anyway, you have clone, right? Once the clone is done, you just blindly execute mn install and make sure that you need to have you are connected to internet, okay, because this will download something. So just execute mn install. It will take some time. Don't try to understand mn install. Just execute it once and then leave it. Think that we have not discussed mn install. Okay, you know what it will do? The moment you execute mn install here, it will compile the main code. It will compile the testing code. Then you have the test related class file, right? So it will execute the class file. If you execute the class file, it will tell you, okay, addition functionality is success or failed. So how many test cases you have, how many pass, how many fail, and things like that. Then you can see the results. And then it will create the jar or var file, whatever you have configured in pound.sml file. and things like that. See how many things it is doing, because Maven is an automation tool. So I'll explain about Yemen install thoroughly in tomorrow's class. For now, think that we have not discussed this, but you just execute it and keep it ready. You just execute it once. Okay. So if you have, okay, sorry. So once you remember these things, and then once you execute this, and tomorrow when I explain Yemen install, you will understand. It's little difficult compared to Git, but I'll simplify it. Clear? Can you do this for me before tomorrow's class?
Yes, sir.
Okay. So that's what I have. Till here you have to practice. Okay. See this, building a sample project. If you still don't have Git, install Git. apt get update, apt get install Git. Just verify if Git is installed. I've given git clone command also. You can use the same repository URL. You are unable to clone. If you are unable to clone this particular repository, means there is some typing mistake. There is some typo. Make sure that you type it properly. Okay. If sometimes it will ask you the username and password. It is asking username password means you have not typed the URL properly. Then just execute and install. Just be ready till this point. Try to remember this. Clear? So I'll stop today's class. If I have any questions, I'm available. Any questions?
Sir, I just tried to run this code again install. It shows a build fail. An illegal reflective access operation has occurred.
Do you have JDK 11 installed?
Yes, sir.
JDK 11.
I installed it, sir.
Just check Java space hyphen version again. And also check if your machine is connected to internet.
JDK version 11.0.19.
That should be fine. Share the screenshot. Sorry, you can share your screen.
Is it visible?
Yeah, 1 second, let me check. Ambient install. ls. You have to execute that in Flipkart folder, not outside of it. Wherever you clone the code, right? There you have to install. Execute that. Remember to execute that command inside Flipkart. So when you run mn install, this is what happens. It will take some time.
We have to execute inside that artifact ID.
Correct.
Okay.
Wherever you have pom.xml file, there you have to execute it. You will understand why tomorrow. You see here it says downloading. Think that it is downloading some Maven related, installation files, some Maven related files. It downloads only once. Once it downloads, next time it will not download. So second time when you run mn install command, it will cleanly show you the output. You won't see all this downloading. Just clear this screen, run Maven install again. So this time when you run, it will not download those Maven dependencies. So it is compiling the main code, testing code, it is generating the reports, it is creating the jar file. Finally, it says build success here. So I'll explain this Maven install tomorrow. You just blindly type.
It will download for first time and it will be in the machine forever.
Yeah, you'll understand that tomorrow, where it downloads and things like that. You can stop your screen lock. Any other questions, guys? Go ahead.
Sir, using Maven, you can also do automation testing.
Automation testing.
Because while running the Maven install command, it was showing test case was successful.
Yes, it is. It will compile the testing code also, and it will also generate the reports. How many test cases pass, how many fail. It can also do that. Only unit testing.
So Maven is kind
No,
of build tool and testing tool.
no. It's a build tool only. Okay. Build, it is what it is doing. It is just building the code. That means it is compiling testing code. And one extra step it is doing, just, it will execute the code and generate the reports. So don't call it the testing code. That's a small, if you take testing as 100%, whatever you're doing here is a kind of a maybe 0.5%. So we don't call it as a testing code. Sorry, a testing tool. No.
Okay.
Sir, is this build happening, doing for the production or staging? How we know that?
Depends. Wherever you deploy it, it becomes that. For example, assume that you're building, okay, Warfare. You deploy it in a mission. This mission name is, you'll be having some name for this mission. Assume that you're copying this Warfare to flipkart-test.com. So testers know their environment URL. This is your environment, right? So they always use flipkart-test.com. You're copying var file into this environment means what? You're deploying the code into test environment and then they access the application. You are deploying the code every day in test environment. So like you work like this for a month, 2 months. So once testing team say that, okay, there are no issues, then one day what you will do, you will take flipkart.var and then you will deploy that flipkart.var into a mission whose name is flipkart.com. Now, assume that it's a, now you know that it's a, I have to release it to the production, the production URL. So you are deploying the var file to production. So this will become production release. You can give any name. So it can be anything. Rajni, any follow-up question on this?
Okay.
Say, for example, you are a DevOps engineer, right? One testing team comes to you, says, I am from performance engineering team. I want an environment, Rajni. So what do? You take a Linux mission, a virtual mission, for example. You decide the name, flipkart-perf.com. You can decide any name, whatever you want, performance.com or whatever. And from next day onwards, just build the var file, deploy it, and send one email to this performance testing team saying, hello, performance testing team. I have created an environment. From today onwards, if for your daily testing, use this particular URL called flipkart-performance.com. So they will use. And every day you will be deploying the code here and they'll be using the same URL for their testing.
Okay, sir.
When you join in real time, somebody will tell you this is the URL for performance, this is the URL our testing team uses for the manual testing and so on. You'll get that information as part of KT.
Okay.
Any other questions for me today? As I said, it's time to practice. If you don't practice and don't get concepts clear, please don't blame me. My job is only to alert you, to understand where you stand. Okay, so practicing and asking questions, getting more and more information is your job. I do my job, you do your job. Okay, thank you everybody. Good night.
Thank you, sir. Good night.